in this video we're going to cover how to determine if an ionic salt is acidic or basic. So there's a few main ideas we need to get across before we start solving some problems. And one of those being that what determines an acid or a base? And the best way I can describe it is the ratio between free hydrogen or hydronium ions, since we talked about in class that these are synonymous. The ratio of hydronium or hydrogen ions to hydroxide ions. So if you have a solution that has more free H plus than OH minus, the solution is acidic. If you have a solution that has more OH minus than H plus, it's considered basic. So this is how you determine an acid or a base. So the key point for when we're determining if ionic compounds or ions alone act as an acid or a base is determining what happens in water. Does this ionic compound compromise the amount of H pluses or OH minuses by binding to them and not letting go? So here's an example, KBr. So if KBr splits apart into water, which it does, it's fully soluble, it creates KOH and HBr. So KOH is a strong base, HBr is a strong acid. So in the water, what this will do is they will completely dissociate into their ions. So at the end of the day, you'll have KOH, or K plus, OH minus, H plus, and Br minus. So the amount of free H plus to OH minus is not changed at all. So the KBr is neutral. Let's look at aluminum bromide. So aluminum becomes aluminum hydroxide when it goes into water, and then the bromine becomes HBr just like we saw before. This is a weak base and a strong acid. The solution would therefore be acidic. We could just say that because there is a strong acid and a weak base. Or we can use the idea of the ratio of hydroxide to hydrogen by looking at what's happening. With a weak base like aluminum hydroxide, the hydroxide is being held onto by aluminum. There is not a full dissociation, meaning at the end of the day, the HBr will split apart, and you'll have H plus, Br minus, a small amount of OH, and most of the OH will be attached to the aluminum, meaning that at the end of the day, you'll have a higher ratio of H plus to OH minus in the solution. The OH will be attached to the aluminum. This is why it is acidic. The fluoride ion. So students get confused a lot because when we talk about hydrogen fluoride or hydrofluoric acid, that is clearly a weak acid because we are adding more hydrogen to the solution by adding the hydrofluoric acid. But just the fluoride ion alone, what it does is it will bind to the H, right? And you'll have the OH minus is going to be just in the solution, untouched, and this HF will create a weak acid. Therefore, the hydrogen will be held onto by the fluorine. So you'll have, at the end of the day, a higher concentration of free hydroxide than hydrogen. So this solution is basic. So fluoride minus is a base. Let's look at ammonium chloride. So ammonium, NH4, we know it will be a positive ion. It will attach to OH once it dissociates in solution. The chlorine will become hydrochloric acid. This means that the ammonium hydroxide is a weak base. Hydrochloric acid is a strong acid. Therefore, the solution is acidic. For the same reason why aluminum hydroxide was acidic, the ammonium, in this case, will stick to the OH and not let go. Since it's a weak base, it'll only partially dissociate that hydroxide ion. So at the end of the day, we have our hydroxides are kind of what we call quenched, meaning they are being taken in by the ammonium and not let go. Then we have our H plus and our Cl minus, which completely dissociate, meaning our ratio is more in the favor of H plus. Let's look at the Fe2 plus ion. So iron will react with hydroxide and make iron hydroxide, iron 2 hydroxide to be exact. So this is a weak base. Now what is happening is this weak base is taking some of the hydroxide, just like we saw for ammonium, and then the H plus is being left untouched. Therefore, the ratio, after it's all said and done, between H plus and OH minus is in the favor of H plus, meaning it is an acidic ion. Magnesium chloride will be the last one we cover. So Mg will go into MgOH2. Chlorine will become hydrochloric acid. Same thing like we saw for the last two, where our hydroxide will be quenched by the magnesium. It'll stick, and our HCl will break apart. And then it'll become a strong acid, weak base. Therefore, we have an acidic ionic compound. But what if, let's do one more bonus example, what if we have a solution that breaks apart into a weak acid and a weak base, such as ammonium fluoride? So ammonium fluoride, it will break apart when it goes into water into NH4OH and HF. Here you have a weak base and a weak acid. So for this case, we need to compare the Ka for HF and the Kb for NH4OH. The reason why is because these values, these equilibrium constants, represent the amount of dissociation or ionization that these two, acid and base, that they have. So for example, if the Ka of HF is higher than the Kb of NH4OH, that means that more H plus will be present in solution after it dissociates than OH, meaning it's an acid. And the Ka of HF is higher. It's 10 to the negative fifth, I believe. And the NH4OH has a lower Kb, which means the Ka will control whether there is more H plus in the solution, and there is. The Kb, if the Kb was higher, let's say for another hypothetical example, if the Kb was higher, that would mean that more OH minus was produced in solution, and the solution was in fact basic. In a nutshell, here is how you determine if a salt or an ion is acidic or basic. And I hope that helps for the upcoming exam, and good luck to everybody. If you have any questions, feel free to write it in the comments and like the video and subscribe.